Welcome everyone, and as you know, this video is a short review of what was covered in class and some of the key components that we need in order to look at stretching and reflecting parabolas. And just as a side note first, recall as we discussed in class today that if a quadratic relation first off is of the form ax squared, and some key parts that you need to know that is if a is greater than 0, sorry, not greater than 0, I wrote 1. If a is greater than 1, we say that this parabola is a vertical stretch by a factor of a. Another important thing is that if a is between 0 and 1, for example, 1/2, this is a vertical compression by a factor of a. And finally, if a is less than 0, in other words, it is a negative number, our parabola is reflected through the x-axis.
Would Mr. Petramali report to the office, please? Mr. Petramali?
And what this basically tells us is the orientation and the stretch of a parabola. And just for some people, I'm going to do another example as well. And let's sketch 3 graphs. Let's do y equals x squared, and that is our parent function. That's the simplest function for quadratics. Let's also sketch, say, y equals 3x squared. And then let's also do y equals, let's say, 1/2 x squared. And furthermore, with that 3x squared, we're actually going to put a negative with it as well. For right now, the only way that we have in our toolbox to graph parabolas is to make a table of values using -2, -1, 0, 1, and 2. And what we're basically going to do in each case is take our x value and square it. So squaring -2 is 4, squaring -1 is 1, and continuing on we get 0, 1, 4. When we're looking at y equals -3x squared, taking our x and y values, we use the same x's each time. And the way that we get our transformation point or our image point is taking each y value from our parent function and multiplying it by the new a value. So 4 will get multiplied by -3 to give you -12. 1 will be multiplied by the new a value to get -3. We'll have 0, -3, and -12 again. And finally, we have 1/2 x squared. Every single time, you notice that we will have the same x values. To get our transformation or image point, we take our parent function of y equals x squared, look at your y values, and multiply each one by 1/2. So 2, 0.5, 0, 0.5, and 2 again. Remember, this here is a reflection in the x-axis. This one here has both a reflection and a stretch. The stretch occurs because of the number 3. 1/2 x squared is only a compression because this is number between 0 and 1. And let us see, very briefly, I'm going to do a sketch of what each of these would look like. I'm not going to be too exact. But if I was to have a Cartesian plane looking exact, y equals x squared, and in class you are given a true Cartesian plane, y equals -3x squared means it must open down, and it's actually going to look a lot skinnier or narrower than the original graph of y equals x squared. Compare that to a vertical compression, and it's a vertical compression, meaning it's pushed down vertically, almost flattens like a pancake, and we have y equals 1/2 x squared for you. Key things that you need to know from this lesson going forward is how to identify stretches and compressions. And direction of opening up or down. That's a very quick 6-minute review of stretching and reflecting parabolas for you.